Dear students, from the topic applications of derivative, today we will solve some examples related to the concept derivative as a rate measures. So let us see first example. A man of height 1.5 meters walks towards the lamp post of height 4.5 meters at the rate of 3 by 4 meter per second. Means a man whose height is 1.5 meters walks towards the lamp post of height 4.5 meters at the rate of 3 by 4 meter per second. By diagram we will represent this. Then what we have to find out? We have to find the rate at which, number one, his shadow is shortening, and second one, the tip of the shadow is moving. So let us see now here. First of all, I will consider OA be the lamp post and MN be the man. Now see this diagram here. As per the assumption, OA is the lamp post, MN is the man, and MB is the shadow of that man, and let us consider X be the length of the shadow here, and OM is equal to Y be the distance between man and lamp post. Okay, so this is Y. Now as per this diagram, what is given to you? See, it is given that man walks towards the lamp post at the rate of 3 by 4 meter per second. See, man is walking towards the lamp post like this, and its rate is given 3 by 4 meter per second. Now as per our assumption, here the distance between lamp post and man is given to you Y. So mathematically, the rate of 3 by 4 meter per second means it is given that dy by dt is equal to 3 by 4 meter per second. Now what we have to find out? See, here dx by dt. What is x? X is nothing but the shadow of the man. So that's why dx be the rate at which shadow is shortening. Means if you want to solve this first question, that we have to find the rate at which shadow is shortening, that means we have to find out dx by dt. It is the rate of rate at which shadow is shortening. So from this figure you will get the clear idea about the question. Now let us see here. Now another information that we want to solve is what is B here. B is called as tip of the shadow, and it is at the distance x plus y from the post. So this is also very important. B is called as tip of the shadow, and it is at the distance x plus y from the post, because in the question we have to find out the rate at which the tip of the shadow is moving. So for that we require this information. So remember this. Now if you observe the figure carefully, then to get the relation between the variable x and y, we have to observe that triangle AOB and triangle NMB are similar triangles. See here, triangle AOB and triangle NMB are similar triangles. Now with the help of property of similar triangle, that is the ratio between the sides of the similar triangles are constant, or in sides are in proportion. So here MB upon MN is equal to OB upon OA. See, we have considered the side of this small triangle as MB upon MN. If you want the ratio between these two sides, then it is equal to OB upon OA. So with this relation we will get the relation between x and y. So that's why as per the given, we know that MB is nothing but x divided by MN. MN means 1.5 because it is the height of the man, is equal to OB. See the figure, distance between OB is x plus y divided by 4.5 means OA, which is the length of lamp post. Okay, now just you solve this. See here it is given. Now if you solve this equation, then we get 4.5x is equal to 1.5x plus 1.5y. Now simplify this, and hence we get 3x is equal to 1.5y, and hence we get x is equal to 0.5 into y. So now this is the very important relation between x and y by using the property of similar triangle. So see here carefully. Now if you differentiate this with respect to t, differentiate this equation x is equal to 0.5 into y with respect to t, then what we get? We get dx by dt is equal to 0.5 into dy by dt. Now dy by dt is given to you. Here 0.5 means 1 by 2 into dy by dt is 3 by 4, and hence we get dx by dt is equal to 3 by 8 meter per second. Now what is dx by dt? It is nothing but the rate at which shadow is shortening. So hence we get the answer of the first question, that is the rate at which the length of the shadow is shortening is 3 by 8 meter per second. So you will get the clear answer from this relation. Now next question is, we have to find out the rate at which the tip of the shadow is moving. Now tip of the shadow is at a distance x plus y from the lamp post. So to find out the rate of that tip of the shadow that is moving, so we have to find out it like this. The rate at which the top of the shadow or tip of the shadow is moving is given by, see, we have to find out the derivative of x plus y with respect to t. See here, d by dt of x plus y, that is equal to dx by dt plus dy by dt, and it is nothing but, see here, dx by dt is already calculated, that is 3 by 8 plus dy by dt is 3 by 4, and by calculation if you observe this carefully, then it will be 9 by 8 meter per second. So if you find out the derivative of x plus y with respect to t, and it is nothing but the rate at which the tip of the shadow is moving, so it will be 9 by 8 meter per second. Now let us see another question. A ladder 10 meters long is leaning against a vertical wall. If the bottom of the ladder is pulled horizontally away from the wall at the rate of 1.2 meter per second, find how fast the top of the ladder is sliding down the wall when the bottom is 6 meters away from the wall. Now first of all we will draw the diagram. A ladder is given to you and it is leaning against a vertical wall. So first of all draw the vertical wall, draw the ladder, and then we will think about this question. So see this diagram. Here the ladder AB is given to you, whose length is given to you 10 meters. Now AC is the vertical wall. Let us consider its length is Y. Now this is the ground X BC. Okay. Now as per this diagram, see here we have written here, let vertical wall be AC and ladder be AB is equal to 10 meters. Now let CB will be X and AC is equal to Y as shown in this figure. Now here what is given to you, dx by dt is given 1.2 meter per second. Now see here, if the bottom of the ladder is pulled horizontally away from the wall, now distance between this bottom of the ladder and the vertical wall is nothing but it is considered as x. Now if you pull this ladder from the bottom, then the rate is given to you, that is 1.2 meter per second. Now if you consider this as x, then it will be dx by dt. So dx by dt is 1.2 meter per second. So read the question carefully, see the diagram, and then write down the given part. Now what we have to find out? We have to find out dy by dt. See here, find how fast the top of the ladder is sliding down, this one. If you pull this ladder from the bottom, then the ladder will sliding down, sliding towards the down. So this distance is y, that's why we have to find out dy by dt mathematically. Find how fast the top of the ladder is sliding down. this one, like this. And when the bottom is 6 meters away from the wall, this is given to you. Okay. Now here we will use the Pythagoras theorem to get the relationship between x and y. So directly all of you know that x square plus y square is equal to 10 square, because this length of the ladder is given 10. So directly we get this equation between x and y. Now if you differentiate this with respect to t, then we get 2x dx plus 2y dy by dt is equal to 0. See the derivative with respect to t. Okay. Now from this, what we get? First of all, we have to find out dy by dt. Now how will you get dy by dt? See here, dy by dt is equal to minus of x upon y into dx by dt. Solve this equation to get this relation, that is dy by dt is equal to minus of x upon y into dx by dt. Now see here, dx by dt is already given to you, that is 1.2. Then x is given here. What is x? X is the distance between bottom of the ladder and vertical wall, and we have to find out the rate, or we have to find how fast the top of the ladder is sliding down the wall when the bottom is 6 meters away from the wall. Means this distance, that is x, is given to you here. So we will put, in place of x, we will put x is equal to 6. But what about y? So for that, when x is equal to 6, see here, with the reference of equation number 1, we will find out the value of y. So 6 square plus y square is equal to 10 square. That is nothing but y square is equal to 64, and hence we get y is equal to 8. So see here carefully. With the help of x, first of all, we have to find out y, because from second equation we will get the final answer. Now equation number 2 becomes dy by dt. We require dy by dt, that is equal to minus 6 upon 8 into 1.2. So here we need to find out the value of y by using value of x. So remember here, dx by dt is given to you, but in this equation we have dy by dt is equal to minus of x upon y into dx by dt. So we need the value of x as well as y, and then dx by dt. Now see the calculation here. We get minus of 9 upon 10 meter per second. If you calculate this properly, then the answer will be minus 9 upon 10 meter per second. Okay. Now the vertical here ladder is leaning down the wall. Okay. So that's why here minus sign is there. But we will write the top of the ladder is sliding down the wall at the rate of 0.9 meter per second. 9 by 10 means 0.9. Here not necessary to write the minus sign here. Minus indicates the rate of change of y with respect to t, where the ladder is leaning in the downward direction. So negative sign indicates the downward direction, but in the answer you can write it as 0.9 meter per second. Okay. Thank you.